Hi there, this is Penelope, and this is a short video on more applications of integration for MG5004 and DE5418. And there'll be some examples on partial fractions, algebraic substitution, and trigonometrical substitution. Okay, the first one. It screams partial fractions, so you need to do the partial fractions first. So let's do that. Let's do that 4x squared plus 1 over x times 2x minus 1 squared. And either from your notes or from the text or from a formula sheet, you can see that the pattern there is a over x plus b over 2x minus 1 plus c over 2x minus 1 squared. And if we multiply that up, we'll get 4x squared plus 1 is equal to a times 2x minus 1 squared plus b times x times 2x minus 1 plus c times x. Now this is going through the partial fraction stuff really quickly because actually I'm doing the integration. So suppose 2x minus 1 is equal to 0, then that makes x is equal to a half, so 2 is equal to a times nothing plus b times nothing plus c times a half, so c over 2, so c is equal to 4. And if we use comparing the coefficients way of thinking, then we've got x squared, using the x squared term, then we'll have 4 is equal to, on the other side, 4a plus 2b. And then using the constant term, we find that there's only 1, so 1 must equal, and we only get the constant of 1 from 1a from somewhere, from here times there. So 1 is equal to a, and that means then we can go back and find that b is equal to 0. So we've now got our c, our a, and our b, and we can put our function that we're going to integrate then as the integral of 1 over x. Remember that b is 0, and we'll take the 4 outside. Like that. Okay. That means, I should have a dx in there. That means our answer is going to be the integral of 1 over x, which is natural log x. Then it will be 4 times 1 over 2x minus 1 times 2 plus c, which is not the same as the previous c. It's the constant of integration this time, natural log x, plus minus, it's actually got to be a minus in there because it's a negative power, so that will be minus 2 over 2x minus 1 because of the cancelling there and there, plus c. Now, in actual fact, that's not a partial fraction one here because it doesn't scream partial fractions. What it does scream is that the top line is somehow related to the derivative of the bottom line, which suggests that we should be using substitution. So we'd say let z equal the function, and then rearranging that we could find that dz is equal to 3x squared dx, and dx then is equal to dz over 3x squared. Now we're ready to go. We can say that this is equal to the integral of 2x squared over z times dz over 3x squared. So our x squareds cancel, leaving us with 2 over 3 times the integral of 1 over z. And that, at that stage, is easy to do because it's on the list. Can't leave it like that. We need to replace z with whatever it was. So it would be 2/3 natural log x cubed minus 4 plus c. Again, we need to check whether this method will work for it. If we look at it carefully, we can see that the top line is related to the derivative of the bottom line. So that means it will be a good one to do like this. So we'd say let z equal x squared minus 4x plus 5. So that allows us to rearrange that to find dz by dx equals 2x minus 4, and thus dx is equal to dz divided by 2x minus 4. Now putting all that in, okay, what we need to look at here is that 2x minus 4, 4x minus 8, maybe in the first instance we take a factor of 2 out, and then we've got what we started with, what we needed to rather. So we can put in the bits. It'll be 2 times 2x minus 4 over z, and dx is dz by 2x minus 4, which is what we wanted, so we cancel that. So it's 2 times the integral of 1 over z dz, and the integral of 1 over z is natural log, so maybe we can put it all back together at the same time. It'll be 2 times the natural log of x squared minus 4x plus 5 plus c. The next one, again, does it look like the top is related to the derivative of the bottom? I think it does. So if we say let z equal cosh x, then dz by dx is going to be sinh, and then dx is going to be dz over sinh. Okay, putting all that in here, what we've got is sinh x over z times dz over sinh x, nothing there, which cancels that, and we're just left with the integral of dz over z, which is the same as 1 over z dz, which is natural log z plus c. Can't leave it like that, so we need to be natural log cosh plus c. Right. For this one, we're going to have to use some fancy footwork to get this one done. It's the integral of negative sine x over all of that. So let's try something different this time. Let's try z equals inverse sine x. So dz by dx equals 1 over square root of 1 minus x squared. This is in your list. So dx is equal to dz over 1 over square root of 1 minus x squared. This is in your list. So now let's put that in. So it's the integral of z times, go away, sorry, just get rid of that. It's the integral of z times 1 over square root of 1 minus x squared times dx, which is dz over 1 over square root of 1 minus x squared. And that, once we cancel everything out, leaves us with the integral of dz, because this one cancels with that one. And that's easy. The integral of z is z squared over 2 plus c, and we know what z was. Z was sine inverse of x squared over 2 plus c. The next one, let's go with z equaling sinh. So dz by dx is cosh, and dx is equal to dz over cosh. So putting that together, then we have, this is now equal to the integral of z times dz over cosh x times the cosh x that's in the question. So cancel, cancel, and again we are just left with the integral of z, which is z squared over 2 plus c, and putting back in what we had gives us the answer. Again, first up we'd need to check if these two were related by differentiation, and yes it is. This second bracket is related to the derivative of the first. So we'd say let z equal x squared plus 7x minus 4. So dx then is equal to dz over 2x plus 7. And we can put that into there. So we've got z times 2x plus 7 times dz over 2x plus 7, and yay, it cancels, so we'll be left with the integral of z dz, which is z squared over 2 again plus c, and we just have to substitute back in again x squared plus 7x minus 4 squared plus c. And the last one I want to go over is one where we have to use a trig substitution, and this is the second of the trig substitutions, where this time we're going to use t is equal to tan x, which gives us that sine x is t over the square root of 1 plus t squared, cos x is 1 over the square root of 1 plus t squared, and dx is equal to dt over 1 plus t squared. Now you're going to use this substitution as opposed to the tan x over 2 when you've got a power. So we've ascertained it's got a power, it's got a trig power, so it will be the right method to use. Okay, so we put all those together, 2 cos squared x plus 1. If you do the algebra and the fraction stuff, you end up with 3 plus t squared over 1 plus t squared. So now your integral becomes the integral of 1 over that, which would be 1 plus t squared over 3 plus t squared dt over, because it was dx. Dx is dt over 1 plus t squared, so that cancels and that cancels, so now we're left with, it's the integral of dt over 3 plus t squared, and that's on the list, and this needs to be something squared, which would be 3, so it would be 1 over root 3 inverse tan t over root 3 plus c, but we would backwardly replace and go 1 over root 3 tan inverse, and it wouldn't be t, it would be tan x, which was our original substitution, over root 3 plus c.